Hi there and welcome to my channel. In this case, we are given a differentiable function f such that f of 4 is equal to 3. And we are given the graph of f prime, and we are also told that the derivative f consists of a semicircle and two line segments. So semicircle we see here, this is semicircle, and then two line segments right here. And we need to find first in question A, f of 0 and f of 5. And recall that by the fundamental theorem of calculus, f of b minus f of a for differentiable function is equal to integral from a to b of f prime of x dx. So in our case, we can apply that too. We have a value at f of 4, and so we can differentiate, integrate the derivative from point 4. And so we get f of 0 minus f of 4 equals integral from 4 to 0 f prime of x dx. And note here, it doesn't matter whether b is greater than a or a is greater than b. This formula works, but we just need to make sure that the corresponding endpoint is the same. So it's 4 corresponds to 4 here, and then 0 corresponds to 0 here. So let's calculate that. F of 0 is equal to f of 4 plus the integral from 4 to 0 f prime of x dx, and this is equal to 3 minus integral from 0 to 4 f prime of x dx. And here we used the properties that you have to change the sign in front of the integral if you change the limits of integrations, if you flip the limits of integration. And so let's see what is this integral. Let's go back to the graph of the derivative, and this is equal to the area of this semicircle. And this semicircle is with radius r equals to 2. But note that this integral from 0 to 4 is actually negative. Negative because it lies, the curve of derivative lies in below the x-axis. So all of this is equal to 3 minus negative area of semicircle minus pi r squared over 2. And this is equal to plugging in instead of r2 gives us 3 plus pi times 4 over 2 equals to 3 plus 2 pi. So the value at 0 of the function is 3 plus 2 pi. Let's similarly find the value at f of 5. F of 5 minus f of 4 is equal to the integral from 4 to 5 of the f prime of x dx. And so f of 5 is equal to 3 plus the area here, the area under this curve between 4 and 5 area. And this is equal to 3 plus, and let's look at the graph again. And this area is this small triangle here, which has height 1 and base 1. So the area is 1/2 base times height, which is 1/2. In this case, 3 times 1/2 equals 3 and 1/2. So the function at 5 equals to 3.5. Let's move on to part B. In this question, we need to find the x coordinates of all the points of inflection of this graph of f for the interval from 0 to 7. And the points of inflection are such points where f prime of x changes from increasing to decreasing, or vice versa. And so let's find such points where on the graph where the derivative changes from increasing to decreasing or vice versa. So here we see that it's decreasing, and then at point 2 it flattens out and then it starts increasing. So point x equals 2 is one such point, and another point it continues to increase here, and then at point x equals 6 it changes from increasing to decreasing. So another point is x equals 6. So there are 2 points of inflection, x equals 2 and x equals 6. Let's move on to question C. In this question, we are introduced with new function g of x, which is f of x minus x. And on what intervals, if any, g is decreasing for this interval, on this interval. And so let's look at the derivative g prime of x, and the derivative is equal to f prime of x minus 1. So really the graph of this function will be the graph that we see only as if it shifted down by 1. So really as if the x-coordinate moves as if this is our new x-coordinate. This will be the g prime of x. And so we see that g is decreasing on the interval where this derivative is less than 0, or on the interval between 0 and 5. G of x is decreasing. Let's move on to the last part, D. Here we need to find the absolute minimum of the function g on the interval from 0 to 7 for this function that we just found. And let's just again draw this new x-axis and see where the derivative, this is x, and this is becomes g prime of x. And so the maximum or a minimum can occur when g prime of x is equal to 0, or at the endpoints, or endpoints. So g prime of x is equal to 0 at x equals 5 at this point here. And the endpoints are also at 0 right here and at 7. So we need to compare. We can see that this is actually a point, this is local minimum. And the derivative before that point, between 0 and 5, it is negative here. And between 5 and 7, it's positive here. So the function is actually decreasing from 0 to 5 and increasing from 5 to 7. So we actually don't need to check the endpoints. We don't need to check them because they will be greater than the value at 5. And so we need to calculate g of 5. G of 5 is equal to f of 5 minus 5 minus x. F of 5 we calculated in part A, so this is equal to 3½ minus 5, which is equal to negative 1½ Thank you for watching. If you liked this video, please don't forget to push the like button. Also, write me your comment below, and also subscribe to my channel, which has more solutions to AP Calculus AB and AP Calculus BC problems. And I will see you in the next video.